In today's video, we are going to be solving equations with variables on both sides. Now remember, a variable is a letter that represents the number. And in these problems, you're going to have variables on both sides of the equation. Now it's really important because I know we're used to combining like terms, but you need to know you cannot combine like terms across the equal sign when solving these problems. So the goal is to do the inverse operations to get the variables onto one side, then it'll become a one or two step equation once you do that. So that's why I stress the importance of drawing the line down the equal sign, because that line tells us I can't combine 3x and 9x. I actually have to do the inverse operation to these in order to isolate the variable. So we have 3x minus 12 over here. We have 9x over here. I want to bring the 3x over here. I want to bring all the x's to one side, and I want to leave the constants on the other, the numbers by itself. So I'm going to subtract 3x from both sides. That way I have, these would cancel out, right? That way I would have all the variables on one side and all the constants, remember to bring down the negative, on the other. Now this is a one-step equation I know how to solve. Divide both sides by 6, and you get x is negative 2. And then you could, again, check it by plugging it back in. Negative 3 times negative 2 is negative 6, minus 12 is negative 18. Negative 2 times 9 is negative 18. Okay, so we want to perform the inverse operations, okay, across that equal sign. Over here, again, importance, bringing the line down the equal sign. Now, before I brought the smaller number over, all right, it did 9x minus 3x. This one, if I bring it over here, this would have to be 0 over here, and that is going to give us an extra step. I don't want to write that extra step, so I'm going to bring the 6x over to this side. So instead, I'm going to minus 6x, and you'll get a negative, which is okay. All right, and you get negative 12 over here. And this one is 2 minus 6x, which is negative 4x. Divide both sides by negative 4. And negative 12 divided by negative 4 is positive 3. So that is my answer, 3. Okay, now if you did it the other way, I'm going to undo this just to show you. You have to be careful because, and you're actually creating more work for yourself, but it won't be a horrible thing if you subtracted 2x from both sides. You would have to remember 2x minus 2x, it just doesn't magically disappear and there's no number there. It would have to be a 0. And then you would have 4x minus 12, right? And then you would solve this like a normal equation, two-step equation, and you get 4x is 12, and you would still get the same answer at the end. But a lot of common mistake a lot of people make when they do that is they make this disappear and go away when it doesn't. All right. So I prefer that you just get all the x's to one side, and then it just becomes a one-step equation to make life easy for you. All right, so let's take a look at the next one. All right, now we have variables on both sides, and we have constants on both sides of the equal sign. I'm going to move this a little bit here. Line down the equal sign. Since I have variables on both sides and constants on both sides, I'm going to bring the smaller of the variables over. So negative 5x is smaller than negative 2x. So I'm going to add 5x to both sides, and that way you'll avoid having negative numbers. I don't like working with negative numbers. So we have negative 2x plus 5x, which is 3x, minus 8, which equals 10. Now becomes a two-step equation. Add 8 to both sides. And we get 3x equals 18. Divide both sides by 3. And we get x is 6. All right, so once we get to this spot where we have a two or one-step equation, we know what we're doing here. All right, threw some decimals in here. They got variables and constants on both sides. So what I'm going to do is bring the smaller one. Again, negative 0.5 is smaller than 0.25. So I'm going to bring this over. Add 0.5x. And again, you can use your calculator if you're not good with doing decimals in your head, but I know 25 cents plus 50 cents is 75 cents. So I try to use the money trick to help me do these problems. Again, it becomes a two-step equation, so I minus 10 from both sides. So I have 0.75x equals negative 18. And then I divide both sides by 0.75. And, oh, not the x. Don't write the x in there. Do not do that. And we get x is, let me use my calculator, negative 18 divided by 0.75 is negative 24. Bam. Negative 24. Good stuff right there. All right, one more. You knew I had to do this. I had to throw in fractions here. I want to separate this guy. That's okay. I'll just leave him here. Fractions with variables on both sides. All right, there's no like terms. So I want to convert this. I want them to have the common denominator. So you look at 4 and 8 and you see, okay, how does 4 go into 8? It goes into it twice, right? So I'm going to multiply this by 2. So 3/4, right? When I multiply the top and the bottom by 2, that's equal to 6/8. So over here, I'm going to write 6/8 instead. 6/8. All right. Now, I'm going to add 1/8 to both sides since 1/8 is smaller. Six eighths plus 1/8 is 7/8. Bring down the 16 and the equal sign and the 2, right? So remember, when you're adding and subtracting fractions, you add the numerators and keep the denominators the same. So 6/8 plus 1/8 is 7/8. And if I converted that to a decimal, let's see what I would get. I'm just curious. 7/8 is 0.875. Okay, so it's not an ugly decimal, but it could work. All right. So now solving this, right, we're going to minus 16 from both sides. And we get 7/8x equals negative 14. To isolate the variable with a fraction, we multiply by the reciprocal. Remember, cancel, cancel. So I have to do that over here too. All right. So we get my answer is 8. Negative 14 times 8 over 7. I know in my head that's negative 16. Here's how I did that. Negative 14 divided by 7 is negative 2 times 8 is negative 16. Or you put in the calculator negative 14 times 8 over 7. Negative 14 parentheses 8/7, and you get -16. And that's my final answer. So remember, with these, it's important to have a common denominator. In order to common denominator, take a look. Okay, we got 4. How does that become 8? You multiply that bottom by 2. Whatever you do to the bottom, you also have to do the top. And that's how I get 6/8 to become there. All right. So that's it for today's video. Work through these problems, and remember, whether you are solving for X or Y, always give math a try.